Chapter 22, number 29, has you drawing optical isomers. So that you kind of see what an optical isomer looks like, is you will have identical looking atoms, same number of atoms, but they're going to be mirror images of each other. So if you look at my molecules here really carefully, you'll see that I'm matching up my front ones, and then like these little tails where they crink out, those match up. And then my red is going to match my red and white here, and my single red is going to match up here. Now this is not a mirror image because it's on opposite sides, so that's not correct. This is a mirror image, exactly straight across from each other. So we want to be careful that when we draw our mirror images that they actually look like I'm holding up a mirror. And you could do that. You could put a mirror when you start drawing these just to see if they look the same. So this is what the problem is asking for. They want you to make a hydrocarbon with a carbon with just a hydrogen. Then they want you to do a methyl, an ethyl, and a propyl group. So let's do that real quick. So I'm going to create a little mirror down the middle. So here's my mirror, and you can even lay a mirror on there if you want to see how it looks. And they said use a single carbon, and carbon has a Lewis dot structure of 4, and that means I have 4 bonding spots. So I'm just going to draw a basic carbon atom with its 4 bonding spots. And the first one asks you for a hydrocarbon, an H. So now I'm going to stick an H on it. Let's say I have an H, and this is me, and this is my right arm, and this is my left arm. Let's say I put an H in my left arm. And I looked in the mirror. Where would my H be? Would it be here? No. Would it be back here? No. It would be right across from it. So that's a mirror image. So then I'm going to do a methyl group. Same structure, same carbon, and this time it's going to be a CH3. So let's say the CH3 is in my right arm this time. Well, then it's going to be here, but if you notice, my H is going to be back here. Okay? So I still have CH3, but my H is in the back, away, and so is this H, a back and away. Remember, mirror images. Maybe you'll see it better in the next one, in the ethyl group. So let's try that. And this time I'm going to put this one down here, CH2, CH3, there's my ethyl. And when I draw it here, I'm going to have my CH2 and my CH3 headed away. So my carbons are going to kind of chain out this way, and my carbons are going to chain out that way backwards. And then I'm going to do my propyl group. And this one I can stick on top, whatever. Okay, and then this one's going to be written backwards. Ooh, I'm out of space. So I've got my C's, H2, C, H2, and see how I'm moving away? C, H3. So like this would be the back of where it hangs out, and that would be the back where it hangs out. So it has to be a mirror image. So that is one way. There's a few ways to do this. You can do it with skeletal structures, but for now I think this is the simplest method to see.